Okay, guys, this problem asks us to solve the following problem. The formula for ethanol is C2H5OH. How many carbon atoms are contained in a 16.7 gram sample of ethanol? So I'm going to solve the problem in the same way that I always have. I'm going to use my three-step method. And the first step of that method is to write down what I'm given. And I'm given 16.7 grams of C2H5OH. Now, you might be wondering what's going on with this formula. It's presented a little bit differently. This is a type of structural formula. What it's doing is it's telling the reader that there is an OH group in the molecule, and that's what alcohols are. Alcohols are have OH groups in them, and so this is ethanol. Okay, so with that aside, 16.7 grams of ethanol is what I'm given. The next step, step two, is to sort out what the problem is asking me to provide. And it actually wants me to figure out the number of carbon atoms contained in that sample. Okay, so having written down what I'm given and having written down what I'm asked for, it's time to start doing some planning, some conceptual planning. How am I going to actually accomplish this goal? So the first thing I do to organize my thoughts is to write down the units in one as I'm going to convert them to the units in two. So the basic idea is that the problem is asking me to take grams of ethanol and figure out how many carbon atoms are in that. So grams of ethanol converted to the number of carbon atoms. Now, there is not a direct per expression. There is not a singular direct conversion factor that allows me to do that transformation. So I have to come up with a series of conversion factors that will allow me to convert grams of ethanol and end up with the number of carbon atoms. Okay, this sequence is actually going to be a little bit more of a challenge than before. What I'm going to have to figure out in this case is that we'll see in a second is that there's actually more than one possibility for this particular plan. And students often get confused when there's more than one possibility because they get confused over which one to choose. Well, the bottom line is choose whichever one is comfortable for you. Both are correct. You get the same answer for both conceptual plans. I'll show you both conceptual plans, but I'm only going to solve for the plan that's on the top, the first one we start to write down. So I know that I can convert grams of ethanol to moles of ethanol by using the relationship established in the molar mass, grams to mole. If I know the number of moles of ethanol, then I can use Avogadro's relationship to convert to the number of ethanol molecules. And I can use then finally, I can use the relationship between the number of ethanol molecules, and I can look at the formula and say for every one ethanol molecule, I have two carbon atoms. So I already, then the next step is my last conversion is accomplished through the application of the molecular formula. So I've got my entire step-by-step plan. First step being Avogadro's relationship, or excuse me, the first step being the molar mass, the second step being Avogadro's relationship, and the last step being a relationship from the chemical formula. Now, what was the alternative pathway? I still start out with grams of ethanol, and with grams of ethanol, I still would want to convert it to moles of ethanol through the molar mass. But once I have moles of ethanol, instead of converting moles of ethanol to the number of ethanol molecules, I can directly use the relationship in the chemical formula and say, if I know the number of moles of ethanol, then I know how many moles of carbon there are. If I know the number of moles of carbon, then I can convert to the number of carbon atoms because I use the same relationship, or use Avogadro's relationship here. So in the first case, I use Avogadro's relationship first, and then the molecular formula relationship. In the second one, I use molecular formula relationship first, and then Avogadro's relationship. Either way works fine. Whichever one you want to do, whichever one pops into your head first, that's the one you should go with, as long as you know that you can do each conversion factor step by step. And so now that we've got that together, let's go ahead and solve the problem using the first plan that we came up with. And so let's go ahead and put that together. I'm starting with 16.7 grams of ethanol. And I know from my step-by-step plan that I'm going to need 3 conversion factors, 3 different per expressions. And so the first per expression, I'm going to see that I'm going to need grams of ethanol to cancel with grams of ethanol so grams of ethanol in the per expression will have to cancel with grams of ethanol in the numerator for the quantity given. And so that establishes that grams of ethanol goes in the denominator of that first per expression. From my conceptual plan, I see that I need to convert that to moles of ethanol. So that tells me that in my per expression, moles of ethanol is in the numerator. So I'm going to go ahead and put in the values, the numbers that make that relationship true. 1 mole of ethanol is 46.07 grams of ethanol. And so now I'm going to do the next step. So the next step sees me canceling moles of ethanol in that first conversion factor with moles of ethanol in the next conversion factor. And then I'm going to use my plan. And I know that from my plan, I have to convert that to the number of ethanol molecules. And so that's Avogadro's relationship. So the number of ethanol molecules goes in the numerator. So that means that it's 1 mole in the denominator and 6.022 times 10 to the 23rd ethanol molecules in the numerator. Okay, I know that I have to take that number of ethanol molecules and it has to cancel with the number of ethanol molecules in the last per expression. But that last conversion factor sees me converting to my final answer, which is the number of carbon atoms. And this relationship is established from the molecular formula. So I have number of carbon atoms in the numerator, and I use the molecular formula to put in the correct values. So for every single molecule, there are 2 carbon atoms. And again, that comes from the formula. So the rest is just some calculator work, but showing you that the units do in fact cancel. Grams with grams of ethanol cancel with grams of ethanol. Moles of ethanol cancel with moles of ethanol. The number of ethanol molecules cancel with the number of ethanol molecules, leaving me with the number of carbon atoms. And the answer rounded to the correct number of significant figures is 4.37 times 10 to the 23rd carbon atoms. Okay, thanks guys.